Hello friends, here we are going to discuss the concept of maxima and minima. So this is a wide concept of differential equations, like how we can use some derivative to find a function's such points where the function is giving a maximum value or it is giving the minimum value. So all these things we are going to discuss in this video. So let's start, guys. Well, maxima and minima, it is giving you a such things to us that where the function is giving you a maximum value, and here we can say that the point of max and minimum value the point of minima, and some saddle point like point of inflections and all these things. So let's see where the function is giving you some maximum approach. So like I'm just, a function is always defined in calculus giving you a graphical representation. Any function you can take, like f of x is equal to x, f of x is y, f of x is equal to e raised to power x, sine x, cos x, or whatever the functions always give you a graphical representation. So I'm just considering one function here, and that function like is reacting like that. This is my f of x. Yeah. So let's see, if you have a function and it is giving you a point of maxima, like a one point where the function is giving you a maximum value. Oh, and somewhere you will see the function is giving you a value where it is quietly infimum, quietly giving you a minimum value, like acting like that, f of x. Now see, if I'm taking a point that is on the height of a function, that point I'm taking, that is point is p. Okay, so here the value function that is known as fp, right? Point value function that is of fp, and this is point that known is a point p. Similarly, you can also consider a point that name I'm giving you, that point is q. So here point is q, and at this point the function's value is fq. Okay, so from both of graph you can see the first graph is showing to you, this is graph number first I'm taking, and this is my graph number second. In the graph number first, you can see your function is approaching to the maximum point, and that point is p. And in the graph number second, you can see your function is approaching to the minimum point, that point is q. So if the function is approaching to a maximum value, that is fp, that is always greater than f of x, like at point p your function will gives you always a greater value whatever the functions. So for all x, whatever the interval is, if you have some intervals, you can write out the interval is x belongs to interval a comma b. You can write out like x belongs to interval a comma b, whatever the interval is given to you. And if there is no interval is given to you, so you can write out for all x. So if fp is greater than f of x for all a comma b means you can consider one interval from a, and that point is just you are focusing the values of this function from this only in between this interval. So your fp is always greater than f of x, so you can say that fp is called the maximum value of function. You can say that fp is maximum value of the function. All right, and what is p? And p is known as point of max. P is known as point of max. Similarly, if you can see in this figure, so if your fq, like this fq is always less than to f of x for all x, it means your fq is minimum value. Fq is minimum value, and your point q is a point of minima, and q is known as point of minima. Clear? Now one more thing, a function can have more than one that point of maxima or minima. Or you can say that, just note it down, function have more than one maxima and minima. It means a functions can approach to maximum or minimum value more than one time, like 3, 4 up to n times. Clear? You could not say, because this complete statement and has same question that appear in the GATE exam. He just asked function have a maxima and minima occurs one time, two time, infinite time, n times. So the n time you can say, you could not say that infinite time. More than one, but up to n times. Like some finite values will be. Okay, now, so function have more than one maxima and minima. So now the point is that how we can find out such a point that where the function is giving a maximum or minimum value. So some two words also consideration with the maxima and minima, that were absolute maxima, local maxima, these kind of points. Let's see. So my dear friends, if you have some function and that is reacting like that here, a function is reacting like that, your required function. Here we can see this is your functions f of x, and here it is x. You can say that x or y is your origin point. My dear friends, here I'm just giving the concept of absolute and local maxima minima. Let's see. If you have some point here and you are just giving a name, that value of this point, that is a, okay, and I want to consider this value in between some interval. Here I'm going to consider some interval that is a minus epsilon, and this is a plus epsilon. So at this point, your function is giving you the maximum value at this point. So it means f of a from a minus epsilon to a plus epsilon. So your f of a, first thing down, at point a, your function is approaching to the maximum value. So f of a is greater than f of x. And here you can say for all x belongs to this interval, and interval is a minus epsilon to a plus epsilon. Whatever the interval you have, like a to b, 1 to 4, whatever, but the specific interval will be there. You can say that a is called local maxima because you have considered some local interval. Okay, local means what? You just specify some interval. You are not talking about the whole things. So f of a is greater than f of x for all x belongs to a minus epsilon to a plus epsilon. So in that case, a is called a local maxima. So a is called point of local maxima. Clear? Similarly, you can find out local minima, and it is called maximum value. So local maximum value, you can ask from. Okay. Sometime you got absolute word also. Okay, if you are here in these functions and this point is named b, this point was a, and see at point b the function is approaching to the highest value. At point b it is giving you highest value, means your f of b will react like that in point. So at f of b is always greater than f of x for all x. Here I'm not giving you any interval, for all x, the complete real line, complete functions, at which point to the tens conditions functions will move at a whole part, your functions will give you a maximum value at the point b. In that case you will say b is called absolute maximum. Is called absolute maximum. Clear? So this is the approach of local, and this is approach for absolute. Now if you want to find out some saddle points are also known as point of inflection. where just a function is changing their position. Okay, sometimes it's just increasing and it start to decrease. So in that case, your function is known as a saddle point. Okay, like the function is moving like that, where it is moving here. So this point is known as point of inflection, or you also known as saddle point. Okay, so it's saddle point also, say that saddle point of inflection. In complete methodology, we will also find out these kind of points. Okay, so after this approach, now time to find the method, like how we can calculate such kind of value, such kind of a derivative to obtain maximum value, to obtain minimum value, as well as the maximum and minimum point. If you got a word that is maximum, so there is no need to worry about that it is local or it is absolute, just you need to find out a maximum. But if he will give you some intervals, so it is specified that you have to find out a local maximum. And methods are same, don't worry about that, methods are same. If the point is of local, so interval will gives to you. Okay, so name is just a little bit changed, but methods will same, and we will see that how we can find a local and how we can go for the absolute maxima. In the problems you will try to understand better. Okay, now time to find the method of find out maxima or minima. There are two type of methods. Method one is a first derivative method. In first derivative method, first of all we have a function that is f of x, and then we will trying to find out the first derivative, that is f dash x, and we will substitute this first derivative is equal to 0. By this equation we got a value of x, like you got a or b, whatever. These kind of values you will find out. After that, what you will do, we will make a real line and we place these values like a and b, and we will check it out like your f dash x, how it's react. Like here it is positive, and here your f dash x is negative, and here your f dash x is positive. So now you will just move from left to right and you will check it out like up to from this point, like it is a positive to negative. If you got a positive to negative, known as point of maximum, known as point of maximum, because somewhere you got a positive result, your positive gradient, and instant it's moving downward, means it's giving a negative gradient, so function is start to decrease, so it means that point was maxima. So that's why after that point your function has start to decrease, and after that you will see at this point it's a negative to positive, and if you got a negative to positive, so that is known as point of mean, is known as point of mean. This was first derivative method, essentially important. This is your first derivative method. It's a little bit approach is similar to increasing and decreasing function for first derivative. Okay, now see, and the second is second order derivative. Second derivative or second order, you can say that second derivative method. What is second derivative method? Second derivative method, first of all we have some function and we need to calculate the first derivative, that is f dash x, and we will replace this is equal to 0. So when you put f dash x is equal to 0, so you got a value of x that will be a or b. I'm just giving example a or b. So after that what you will do, you will just find out the double derivative of this function, and we will substitute the value of x, like x is equal to a or x is equal to b. We will check it out. If your f double dash x at a, it is giving you a positive result, so this point is of minima, and if at some point like at b it is giving you a negative result, so this is point of maximum. The point of minima is giving a positive gradient, positive result of double derivative, it is point of minima, and at negative, so it is point of maxima. And if you got f double dash at some point like at a or at b, or I'm just taking at c at x is, so at point c this is given to you 0. So in that case you can say it is neither minima nor maxima, so it is point of inflection. or saddle point also you can say that, point of inflection. Clear? So this is a methodology behind Maxima and Minima, and here we will use this methodology to find out some important logics, and I will give you some examples at how we can solve out the problem of maxima minima with the help of first derivative method as well as with the help of second derivative. So I hope so that it is useful for you. So thank you so much for watching this.